All right, good morning, everybody. We're going to start talking today about proportions, okay, and what strategies we can use to solve them. So, definition of a proportion is an equation stating that two ratios or rates are equivalent. Again, equivalent just means equal, okay? So, here we have a ratio 1 to 2. Here we have a ratio 3 to 6. Each of those individually is ratios. A proportion is a statement that says they're equal. So 1/2 equals 3/6 is a proportion. Okay, similar 24 to 30 equals 8 to 10 is a proportion. In order to be proportionate, it has to have two ratios with an equal sign between them. Okay, and we can check to make sure those are true. Remember, the way that we had to check if those are true is to see if they reduce to the same thing. So 1/2 is already reduced. 1 to 2 is reduced. 3 to 6, if we try to reduce that, you should be able to see 3 goes into both of those. So if we divide the top amount by 3, we would get 1 over 2. Right, so the same thing. Here, if we try to reduce these, if I look at 24 and 30, I can see that 6 goes into both of those. So if I divide both of those by 6, I get 4/5. Okay, looking here, 8 and 10, I can see that 2 goes into both of those. So dividing by 2, I get 4/5. Okay. So they reduce to the same thing, which means those ratios are equal. All right, now I told you that I would show you another way to check if ratios are equal. So we're going to do that right now. So I'm going to start with this first one. 1/2 equals 3/6. And we're going to notice something about true proportions. Might blow your mind a little bit. Okay, so here's what we're going to notice. What do you get if you do 1 times 6? You get 6. What if you do 2 times 3? You get 6. We got the same number. Was that a coincidence? Well, let's find out. Let's try the other one. 24 to 30 and 8 to 10. We know from checking that these ratios are equal. Let's see what happens when we find the cross products. That means when we multiply the numbers on the diagonal. Okay, well, 30 times 8, 3 times 8 is 24. So 30 times 8 is 240. Okay, what about these diagonals? 24 times 10. Well, multiplying by 10, which means to add a 0, right? So 24 times 10 is also 240. Okay? And this is not a coincidence. This is a true thing about proportions. Anytime you have a true proportion where these are equivalent ratios, you'll get the same thing when you multiply these diagonal numbers and when you multiply these diagonal numbers. And that is another way that we can check to see if ratios are equivalent, other than reducing them. Reducing them still works, but this gives us another option that's sometimes easier. So let's take a look at this example. So this example says 120 calories in 2 servings. That's the ratio of calories to servings. Okay, or 360 degrees in 360 calories in 6 servings. Okay, so we got a ratio of calories to servings. Okay, so I can check to see if these are the same by multiplying the diagonals and see if I get the same thing. So let's start here. 2 times 360. Well, 300 times 2 is 600. 60 times 2 is 120. If I add this together, I get 720. Okay. On this side, 120 times 6. Well, 100 times 6 is 600. 6 times 20 is another 120. That is also 720. Okay, so I get the same thing, multiplying both diagonals. That means that is a true proportion. Okay. If I were to reduce these, this would reduce down to 60 over 1, divided by 2. Here I could divide the top and bottom by 6 and also get 60 over 1. Okay, so they both reduce to that, okay, which still works. Okay, but here's a new method that we can use to check to see if they're equal. Okay, so we can check to see if ratios are equal that way, but those will also give us a way to solve proportions. So there's going to be situations in which we have a proportion, but where we don't know one of the numbers. Right? So 4 to 9 is proportional to or is equal to something to 18. Okay, we might need to figure out what this number is. Now there's a couple of ways we can do that. If you have good proportional reasoning skills, or remember what we did with equivalent fractions, you might just notice that to get from 9 to 18, all you have to do is multiply it by 2. Okay? So if you multiply the 9 by 2 to get 18, you can multiply by 4 by 2 to get 8. Okay, so that is one way you can solve it. Okay, just using that equivalent fractions idea. Because remember, fraction is a type of ratio. Okay, so we should expect this to be 8. The other way that we can do this is by using those cross products. And this is kind of the method that we're probably going to use most. Okay, so I don't necessarily know what x is, but I do know that if this is a true proportion, multiplying these should give me the same thing as multiplying these. Okay, so I'm going to start by doing 18 times 4. So 18 times 4 is 72. Okay, so these multiply to 72, which means these would also have to multiply to 72. Okay, so 9 times something is going to give me 72. To find out what that something is, I'm just going to divide by 9. 72 divided by 9 equals 8, okay, which we saw that it was going to be. So we multiply the two numbers that are across from each other and then divide by the one that's across from the number we're trying to find. Okay, so if I try that on this one, let's start 15 times 6. That's the numbers that are diagonal from each other. 15 times 6 is 90. Okay, and then I divide by 5. Okay, because I know 5 times something should give me 90. I want to know what that something is. So if I divide it by 5, I get 18. So G is equal to 18. Okay. If I check to see if this is one I could have used a shortcut on, if you think about these two ratios, you might notice 15 is 3 times as big as 5, which means this number should be 3 times as big as 6. And if I check, it is. 6 times 3 does give me 18. Okay, so because the cross products have to be equal, the way that we can do this is we can just multiply the, we'll start with the number that's above the variable or below, but it's in the same side as the variable. Multiply it by the diagonal and then divide by the other one. That'll give us the answer. And because of that motion, we call this sometimes the fish method. Okay, so let's try it. So if I want to know what R is, I'm going to start with the one in the same fraction, the same ratio, and multiply across. So 25 times 4 is 100. Okay, then I'm going to divide by this number, 5, and that gives me R, which is 20. Okay, so see how we're starting the number by the variable, going diagonally across, then dividing by the last number to get what I'm looking for. So R should be equal to 20. 4/5 is the same as 20 over 25. Okay, right, again, recognize 5 times 5 is 25. 4 times 5 is, in fact, 20. Okay, let's do another one. All right, so I'm going to start with the 10. Do 10 times 4 is 40. Okay, then I'll go up here and I'm going to divide by 20. And that will give me what M is. So 40 divided by 20 is 2. Okay, so M is 2. 20 over 4, or 20 to 4, same as 10 to 2. Again, you might notice 10 is half of 20, 2 is half of 4. So proportionally it fits. Okay, so here's our homework. We're going to be practicing some of that. Remember, there's a couple different ways to do it. You can just think about rewriting it like it's an equivalent fraction by multiplying or dividing. You have to multiply or divide the top or bottom by the same thing. So you can do it that way, or you can do the fish method where you